Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into
How
it.
an internal combustion engine works. The first piston motors had only one cylinder with a small diameter. In the process of development, to increase power, the cylinder diameter was first increased, and then the number of cylinders was increased. Gradually, internal combustion engines took the form we are accustomed to. The motor of a modern car can have up to 12 cylinders. CCHM, crank and connecting rod mechanism. Timing, mechanism for adjusting the timing of gas distribution. Lubrication system. Cooling system. Fuel supply system. Exhaust system. Also to the internal combustion engine systems include electrical starting and engine management systems. CMM, crank and connecting rod mechanism. CMM is the main mechanism of a piston engine. It performs the main work, converts thermal energy into mechanical energy. The mechanism consists of the following parts: cylinder block, the head of the cylinder block, pistons with pins, rings and connecting rods, crankshaft with flywheel. The timing gear is the timing mechanism to ensure that the right amount of fuel and air enters the cylinder and that the combustion products are removed from the combustion chamber in time. The internal combustion engine has a mechanism called the timing mechanism. It is responsible for opening and closing the intake and exhaust valves, through which the fuel-air combustible mixture enters the cylinders and exhaust gases are removed. The parts of the timing gear include the camshaft, inlet and exhaust valves with springs and guide sleeves, valve drive components, elements of the timing gear. The timing chain is driven from the crankshaft of the vehicle engine. With the help of a chain or belt, the rotation is transmitted to the camshaft, which by means of cams or rocker arms through the tappets presses on the inlet or exhaust valve and opens and closes them in turn depending on the design and the number of valves. The engine can be fitted with one or two camshafts for each row of cylinders. In a two-shaft system, each shaft is responsible for operating its own row of valves, either intake or exhaust. The single-shaft design has the English name SOHC, single overhead camshaft. The system with two shafts is called DOHC, double overhead camshaft. Engine cooling system. When an engine is running, its parts come into contact with the hot gases that are produced by the combustion of the fuel-air mixture. In order to prevent the internal combustion engine parts from being destroyed by excessive expansion during heating, they must be cooled. A car engine can be cooled using air or liquid. Modern motors have, as a rule, a liquid cooling scheme, which is formed by the following parts: engine cooling jacket, pump, thermostat, radiator, fan, expansion tank. The cooling jacket of internal combustion engines is formed by the cavities inside the cylinder block and cylinder head through which the coolant circulates. It draws excess heat from the engine components and carries it to the radiator. Circulation is provided by a pump driven by a belt from the crankshaft. The thermostat provides the necessary temperature mode of the car engine, redirecting the flow of fluid to the radiator or bypassing it. The radiator, in turn, is designed to cool the heated fluid. The fan amplifies the rushing air flow, thereby increasing the cooling efficiency. An expansion tank is necessary for modern engines, as the coolants used expand greatly when heated and require additional volume. Engine lubrication system. There are many rubbing parts in any motor that need to be constantly lubricated to reduce power loss due to friction and to avoid increased wear and seizure. A lubrication system exists for this purpose. In addition, it helps to solve several other problems: protection of internal combustion engine parts from corrosion, additional cooling of engine parts, as well as removal of wear products from the contact points of the rubbing parts. The lubrication system of the car engine is formed by oil sump, oil pan, oil supply pump, oil filter with a reducing valve, Oil pipelines. Oil dipstick, oil level indicator. System pressure gauge. Oil filler neck. The pump draws oil from the oil sump and feeds it into the oil lines and channels located in the BC and cylinder head. These pass oil to the contact points of the rubbing surfaces. Supply system. The supply systems for spark ignition and compression ignition internal combustion engines are different, although they share a number of common elements. The common elements are fuel tank, fuel level sensor, fuel purification filters, coarse and fine, fuel pipelines, intake manifold, air connections, air filter. Both systems have fuel pumps, fuel ramps, fuel injectors, but due to the different physical properties of gasoline and diesel fuel, their design has significant differences. The principle of fuel supply is the same. Fuel from the tank with the help of a pump is fed through filters to the fuel ramp, from which it enters the injectors. But if in most gasoline internal combustion engines injectors feed it into the intake manifold of the car engine, in diesel engines it is fed directly into the cylinder, and there it is mixed with air. The parts that provide air purification and its supply to the cylinders, air filter and pipes, also belong to the fuel system. Exhaust system. The exhaust system is designed to remove exhaust gases from the cylinders of the car engine. The main parts, its components are exhaust manifold, receiving pipe of the muffler, resonator, silencer, exhaust pipe. In modern internal combustion engines, the exhaust design is supplemented by emission neutralization devices. It consists of a catalytic converter and sensors communicating with the engine control unit. The exhaust gases from the exhaust manifold pass through the intake pipe to the catalytic converter, then through the resonator to the silencer. They are then released into the atmosphere via the exhaust pipe. Finally, it is necessary to mention the starting and engine management systems of the car. They are an important part of the engine, but they must be considered along with the electrical system of the car, which is beyond the scope of this article, looking at the inner workings of the engine. Deviceinternal cylinder crank mechanism, timing system, engine cooling system, internal combustion engine lubrication system, internal combustion engine feeding system. In conclusion, the piston-type internal combustion engine remains a cornerstone of automotive technology, driving the performance and efficiency of countless vehicles worldwide. Understanding its operational principles not only highlights the ingenuity behind this device but also underscores its significance in the evolution of transportation. As we look to the future, the ongoing advancements in engine design and alternative technologies will continue to shape the automotive landscape, ensuring that the legacy of the internal combustion engine endures while adapting to new challenges. Thank you for watching, and we hope you gained valuable insights into this fascinating topic.